Hey everyone, today we're going to be working through section 4.3, day 1, and we're going to be talking about the derivatives of inverse functions. This is going to be pretty different from everything we've done so far with taking derivatives. So this is probably going to be a video that you're going to want to watch more than once because it is so different from all the other rules we've learned for finding derivatives. So before we dive into finding the derivatives, we're just going to do a review of what inverse functions are. So generally speaking, an inverse function is just a function whose equation undoes another equation. So for example, if my function were f of x equals 2x, then my inverse function is going to be x over 2. So where I had multiplication, the inverse is going to undo that with division. So now let's go ahead and take a look and see how we find inverse functions. So if we have an equation, this is just a review of some stuff you already know. To find the equation of the inverse function, we're going to switch the x and y, and then we're going to solve for y. So let's go ahead and do an example together. Here I have my function f of x equals 3x cubed minus 5, and they're asking us to find the inverse. So the first thing I'm going to do is I'm going to replace f of x with y. And then I'm going to go ahead and do that step 1, which is just switching x and y. So I have x equals 3y cubed minus 5. And now I'm going to do the algebra that I need to do to get y by itself. So first, I'm going to add 5 to both sides. Next, I know I need to divide both sides by 3. And then the last thing I'm going to do is take the cube root of both sides. So there's my inverse. Now, I'm not going to leave this as y. I'm going to go ahead. I know I was finding the inverse, so I'm going to go ahead and use that notation. So f inverse of x is equal to the cube root of x plus 5 over 3. And if you compare that to the original function, you can see how we've kind of undone those operations here with the inverse. Now, that works out really nicely when we're able to solve to find the inverse with algebra, but sometimes it's actually impossible to find that inverse function using algebra, which is something that's going to complicate finding the derivative a little bit, but we have a way of getting around that. The next thing I want to look at is if we have tables. And so the idea here is that since inverse functions undo each other, the x values of the original function become the y values of the inverse and vice versa. So, for example, if I were given this table down here, I have a table for f of x right here and a table for the inverse. All that happens when I take the inverse is that the x values of the function actually become my y values of the inverse. And the y values of my function become the x values of my inverse. And this right here is one of the big ideas we'll be using when we start taking the derivatives of inverse functions. So I want to make a note here that the inputs of the function are the outputs of the inverse. Okay, so the inputs of the function are the outputs of the inverse and vice versa, right? So we could also say the outputs of the function are the inputs of the inverse. Again, that's going to be key when we start working with these derivatives. So then the last thing we just want to touch on is when we're talking about inverse is how that plays out graphically. So, to make the graph of the inverse function, we can either find the inverse function's equation and graph it, so kind of do what we did back here on the left side, actually find that inverse and graph it. We could use our table of values, right, to switch the x and y before graphing, or we can reflect the graph over the line y equals x. Right, so in this case, if I take that line y equals x, let's see, I'll use my ID here. There's a little straight edge. Let's see. Oops, it should be here. It's not going to be perfect, but let's go ahead and draw that in. Okay, there's my line y equals x, and so I'm going to reflect those points over that line. So if I see here, I've got a point, this point is going to go here. Right, this point is still on that line, but then if I were to connect that up, my inverse is going to look like this. Oops. So that's the idea of reflecting it, but I could also compare the points here. Let's take this point on my function. So I know that point is 4, 2. If I look on my curve here on the inverse, I have the point 2, 4. Which makes sense because we said those x and y coordinates get switched. All right, so let's look at a problem that's going to kind of lead us into how we find derivatives of inverse functions. All right, so for number 1, we're actually given an equation for f of x, and we're asked to find a few things. So the first thing we're going to find is f of -1, which is definitely the easiest of all the things we're going to need to find. So f of -1 is just -1 plus 3, quantity cubed. So I'm going to have 2 cubed, or 8. Okay, so that tells me that I know the point -1, 8 is on my curve. Now, I want to look at part B 2 different ways. If we remember, this is asking about the inverse. So it wants to know f inverse of 8. Now, remember, we said the input of the inverse was the output of our function, which matches here. The x value of our inverse matches the y value of our function. And then we said, well, now the output of our inverse should be the input of our function. So my y value for my inverse should match the x value. So what I would expect is that would be -1. So let's actually go ahead and calculate that inverse and see if that holds. So I'm going to rewrite my equation just with y here as x plus 3 cubed. To find the inverse, I'm going to switch these. And then I'm going to solve. So I've got the cube root of x is equal to y plus 3. So y is equal to the cube root of x minus 3. So that is my inverse. Is the cube root of x minus 3. I'm sorry, I'm kind of all over the page here. So now if I wanted to find f inverse of 8, I would have the cube root of 8 minus 3. Well, the cube root of 8 I know is 2 minus 3 is a -1, which is what we thought up here. Again, remember this idea came from saying that the x value of the inverse is equal to the y value of the function. So the y value of this inverse should be equal to the x value of that function. All right, now let's look at f prime of -1. So I'm going to jump up here. F prime of -1. Well, first I need to know what f prime of x is. And so here we're going to do a chain rule. So I have 3 times the quantity of x plus 3 squared. Derivative of the inside is 1, so I'm good there. So now if I plug this in, I'm going to get 3 times -1 plus 3 quantity squared, or 3 times 2 squared. 2 squared is 4 times 3 is going to be equal to 12. All right, now in part D, I want to know what f inverse prime of 8 is. So in other words, what is the derivative of the inverse at the value of 8? So we actually solved for this inverse. So let's see. Our inverse here, that was cube root of x minus 3. So now I'm going to use power rule to find that derivative. So f inverse prime of x. I know this is x to the 1/3, so I have 1/3 x to the negative 2/3, or 1/3x to the 2/3. So there's my derivative. So now I'm going to evaluate that derivative at 8. So f inverse prime of 8 is 1/3 times 8 to the 2/3. Now remember, 8 to the 2/3, that just means we're going to take the cube root of 8, which is 2. We're going to square that, which is 4. And then 4 times 3 is going to give us 12. So that's going to be equal to 1/12. All right. Now, hopefully you're noticing something here. And this is what we're going to talk about in the next section. The question is asking us, what do you notice about f prime of -1 and the derivative of f inverse at 8 in the previous example? So if I look, f prime of -1 was equal to 12. And the derivative of the inverse, evaluated at 8, was 1/12. So hopefully what you're noticing is that the derivative of the function the derivative of the function and the derivative of its inverse are reciprocals, right? Though they're just flipped. And this is going to be the other big piece to helping us find these derivatives of inverse functions. So if I know the derivative of a function, I know the derivative of its inverse is just the reciprocal. Okay, we're going to use this idea to make a shortcut for finding the derivative of the inverse of a function. Okay, it's necessary for several reasons. So it's definitely quicker, and it's oftentimes a little bit more simple. And more importantly, it's not always possible to find the derivative of the inverse function using algebra. Sometimes we just don't have the methods to do that. So sometimes this method is going to be the only way that we can find that derivative. So for those reasons, it's going to be really important that we know this process. So let's go ahead and take a look at some problems. We're going to look at a couple different types of problems. This is kind of a standard one, and then we're going to look at how these really look when you come across them on the AP test. So let's say that the problem asks you, given a function f of x, it asks you to find the derivative of the inverse at a given x value. Okay, we said that we know that the derivative of the inverse is the reciprocal of the derivative of the function. So first we're going to define the derivative of f of x. And then we're going to write 1 over f of x, right? There's that reciprocal relationship. The derivative of the inverse is the reciprocal of the derivative of the function. And so this would actually say 1 over f prime of x. Now, the next thing we're going to do is calculate the x value that corresponds to the given y value. And this step may not always be necessary. Actually, with most AP problems, you don't have to do this step, but we'll talk about what I mean when I say that as we go through the example. Then the last thing we're going to do is plug in the x value. So here at this point, I think it's definitely worth watching how this happens. Maybe just put down your pencil for a minute, watch what happens, and then you can go back and fill in the notes. So here's what I know. I need to find the derivative of the inverse, and it wants to know when that value is 1. So here's what I know. I know the derivative of the inverse is the reciprocal of the derivative of the function. So that's that reciprocal piece, my 1 over f prime. But now I have to figure out what value to plug in here. So here's what I know. This is my inverse function right here, f prime. So I know that my inverse has an x value of 1. Based on what we said earlier, that means my original function must have a y value of 1. Remember we said we switched those. The x value of the inverse is the y value of the original. My problem is that I need an x value here, right? This needs to be an x value, and I don't know that. So here's what's going to happen. I go back to my original function, f of x. I know that's x to the 5th plus x plus 1. And I know that must be equal to 1. So now I can go ahead and solve for the value of x. So if I subtract 1 from both sides, I get x to the 5th plus x, and that equals 0. Well, right off, I know the only way to get 0 for that is if x is equal to 0. So now I know that x value from my original function, and that's what I'm going to plug in. I'm going to find f prime of 0. So now I actually have to do another step. I have to find f prime of x, which is 5x to the 4th plus 1. So if I plug 0 into here, I just get 1 over 1, which is 1. So what I just found out is that the derivative of the inverse when x equals 1 is 1. Okay, we're going to look at a few more problems. Okay, so these problems look very similar to the one that we just did. And I think we'll just do one of these for time's sake here. Then we'll look at some AP problems, and we could talk more about these in class tomorrow because I think we're definitely going to need some more examples to fully get this. So here we go. We're given a function f of x equals x cubed minus 1. We want to find the derivative of the inverse when the input of that inverse is 7. So here's what I know. I know that the derivative of the inverse is equal to the reciprocal of the derivative of that function. Now again, this is my inverse right here. So I know my inverse has an input of 7. I'm not even going to worry about the output there because what I need to know now is that my original function, if the input of the inverse was 7, my original function must have an output of 7. And that's going to, again, help me solve for this x value that I need. So I'm going to go back to my original function, x cubed minus 1. And again, I know that y value has to be 7. So I have, if I add 1, x cubed is equal to 8, which tells me that x is equal to 2. And now I can plug that value in for my original. And since this is the original, the derivative of the original here, I'm going to use that x value. So f prime of 2. Because again, this is the derivative of my original function. Now, f prime of 2 is something that's easy to calculate. If f of x was x cubed minus 1, f prime of x equals 3x squared. So now if I plug in 2, I get 2 squared is 4, times 3 is 12. So my derivative of the inverse is 1 over 12. Okay. I'm going to leave number 2 for right now. Let's go ahead and review that when we come to class. I do want to look at, I think we'll just do one of these problems here for now. This is a very popular question that you might see, particularly on the multiple choice for the AP exam. So a lot of times you don't get an equation at all, you just get a table of values. And so you need to know how this process applies when you're looking at a table of values. So let's go ahead and take a look. Again, we're going to work with the same idea that we've been doing. I know that I need to find the derivative of the inverse of g at the value 1. Again, if I'm finding the derivative of the inverse, that has just a reciprocal relationship with the derivative of my original function. Now, again, my question becomes, what x value do I put here? So let's take a look. My inverse function right here has an input of 1, which tells me my original function g must have an output of 1. So now I go back to the table, right? And I want to say, where does g have an output of 1? So I'm going to look in the column for g, and I find the value of 1 happens when x is -1. So now I know that I need to plug in a -1 right here. So now I go back to the table. I'm going to use the g prime column. So g prime of -1 is a -1/5. So my derivative here is 1 over a -1/5. And if I simplify that, that gives me a value of -5. We're going to be working a lot with these types of multiple choice problems because, again, they will come up over and over again. For right now, I think that's probably enough. So that gives us 3 problems to kind of go over, flush out any questions that you have. We can go over those before you start your practice in class. So again, please do watch this a couple times if you need to, so you can kind of figure out where you're clear and where things are maybe a little bit confusing. And we will work through this a lot more over the next couple days in class. That's all for today. See you in class.